In this video, we're going to take a look at the Lagrange polynomial. So we're going to try to interpolate a function. We're trying to identify this interpolating polynomial that says if we know a couple specific points on our function, can we use a polynomial to approximate it? And we're going to build that polynomial not by the Taylor series method, but instead by constructing an interpolating polynomial. So we're creating a polynomial that agrees with a function at certain points. So in a linear case, if we are going to define a line, we need to have two different points. Those two different points, we will call those points x0, comma f of x0. And then the second point we will call x1, f of x1. Now notice we have 2 points, but the subscript on our second point is 1. So the largest subscript we only get is 1, even though we have 2 points, because we have that subscript of 0 as well. If we have 2 points, we can generate not just a line, but we can generate a unique line that goes through those points. And we can take this idea and we can generalize it, and we can say, oh, if we have n plus 1 points, so starting with x0 and the function value at x0, all the way up through xn and the function value at xn, if we have n plus 1 points, then we should be able to generate a polynomial of degree n that goes through those points. And that's the plan. All right, so let's talk about the linear case. So for the linear case, what we can do is we can define this L0 of x, and that the way that we will define that is we will take x. So this is a variable x, not a known value of x. We're going to take a variable x minus x1 over x0 minus x1. Right? So the values with the subscript, those are known points, right? So from up here, we have those are known x values. That's how we'll define L0. The way that we define L1 is the same, but kind of backwards. So we have x minus x0, and then x1 minus x0. Those aren't the polynomial, those are building blocks to the polynomial. And so then the way that we define our interpolating polynomial, our Lagrange interpolating polynomial, so we're going to take L0 of x times the function value at x0 plus L1 of x times the function value at x1. And so when we look at this, we have this is just a number, this is just a number. The only variable we still have is this x here. We'll have this x here that show up in here and here respectively. Right? So you'll have something that's linear, right, in terms of x for this piece. And then for this piece, it's also going to be linear in terms of x. So this whole thing is just describing a straight line. Now, does that line go through these 2 points, right? So that's the kind of polynomial we're hoping to construct. Does it go through those 2 points? So let's check that out. So let's plug in to this Lagrange polynomial. Let's plug in x0. So x0 would be L0 of x0 times f of x0 plus L1 of x0 times f of x1. Right? So we have anywhere that we had just an x before, here we are replacing it with an x0. what happens when we evaluate those? So what is L0 of x0? Remember, L0 of x0 is this. So we're replacing this x with x0. So we have x0 minus x1 over x0 minus x1. So regardless of the values of x0 and x1, that's going to come up 1 absolutely every time, times f of x0. And then for our second piece, when we plug things into x0 into L1, this is how L1 was defined. If you plug in x0 here, you have x0 minus x0, so you're going to get 0 for that term. And so, when we plug in x0 to the polynomial, the output is the function value at x0. So it at least agrees at the point x0 comma f of x0. Now if we were to plug that into the second point in to our Lagrange polynomial, then we get, this is going to go to 0, right? So when you plug in x1 right here, you're going to get 0 over something. So we get 0 times f of x1. Actually, that should be f of x0, sorry. Plus, when we plug in x1 into this piece, we have x1 minus x0 on top over x1 minus x0. So we'll get 1 every single time, times f of x1. So the line constructed in this way does in fact go through both of those two endpoints. Excellent. So how do we generalize this? How do we have this do the same thing for lots and lots and lots and lots of points? And that's what we will talk about in our next video.